Factorising. Christian, what actually is factorising?
Taking something that's been expanded and putting it into factorized form.
Yeah, okay, cool. So we're something that's expanded and putting it into factorized form. I love how in the definition you also use the word again though. So it's always tricky to define words because you often go back to using the word that it is. Yeah. Introducing brackets. That's not bad. So when Christian said, oh, I want something in a factorized form, we usually say, oh, there's some sort of brackets involved, right? Another thing to think about is, well, hang on, what does this word actually mean, a factor? If I say 6, right, 6 has factors. What are the factors of 6? 3 and 3. 3 and 2, yeah, right. It's right, it's a Thursday afternoon. 2 and 3, or 1 and 6, right? These are the factors. These are factorized because these two numbers, when they're multiplied together, they make up 6. Okay. So factorizing can either be thought as introducing brackets or thinking about what things multiply together to give you that expression. Right? Just really quickly, we've learnt various methods in factorizing, and I have 3 terms I've called them. I say there's the simple way of factorizing, there's the grouping in pairs method, and there's when we have trinomials. The important thing to realize is when we're asked to factorize, okay, they can give us any kind of expression and we should be able to factorize it. But the way we go about factorizing that is going to be different in different circumstances, right? For the simple method, we usually look for what's in common. I'm usually looking for what's in common here. So, as an example, this expression here, I look at my 2 terms and I'm saying, okay, what's in common with these terms here? Well, I can see there's a y in common, so I'm going to take that factor out, right? I've got a factor of y, and that's multiplied by, well, whatever inside here. And if you want to think about taking something out, that's the process of dividing, right? If I divide this by y, well, I get left with y minus 2. And how can I check that's right? Expand it back out, right, Sam? Yeah. So if I expand this back out and I go back to here, then I know I've reached the correct answer, which is what Christian was saying, because it's basically taking what you have in the expanded form, right? Expanded form, and then checking it into those brackets or those factorized forms there. Yeah. And they won't always look the same though, which is the tricky thing, right? And we sort of have to decipher what's actually going on here. If I have a much longer expression like this, right? Is there anything in common between these terms here?
X plus 3.
Okay, thank you. X plus 3 is in common, right? So even though that's a, 2 terms actually, right? I can still take that out because it's something in common, right? It's something that I'm taking out, so I'll put that outside there. What do I get left with though? 5 and, yeah, okay, so I get left with a 5. And I also get left with plus 2y. Okay. So that's how I can factorize something like that. That's right. Okay. So again, factorizing. We're introducing brackets. Maybe we're looking for what's in common. I look at this though, and I see there's some x's here, but x is not in common throughout the whole expression, right? And so that's where we have to be able to comfortable between all these different methods and realize which one we're being asked to do. If I've got something like this, I can't find something in common which is with everything, but there is something else I can do. Yeah? Say it louder, can't you? Oh, they can actually. I didn't even realize that. That's a good point. Not quite what I'm looking for because I'm trying to show something else. But yeah, we'll get onto that later. Yeah.
So you just split it in 2.
So we've already split it in 2, and then what do we do next?
X outside X minus 2.
Ah, yes. Okay.
And then 3 outside X minus
Yes, right, okay. So we could group these together, but then we're going to have to do an extra step and use another factorization method. So instead of doing that, when we have 4 terms, that's when we will look for the grouping in pairs method of factorizing, right? So when we have 4 terms, 1, 2, 3, 4, all separated by addition and subtraction, that's when we want to look for the grouping in pairs method, which is essentially saying, okay, let's look at some pairs here. I can't see something in common between all of them, but if I look at the first 2, there's something in common there. If I look at the second 2, there's something in common here, right? Laura realized, hey, in common with the first one, there's x outside of x minus 2. And same thing here, there's something in common here. What is it? 3. Yep, so 3 is in common. Yeah, right. 3 outside of x minus 2. And then that looks very similar to this expression here. I can see that this expression here is in common. So I can take that out again. That's, again, using our simple method. So sometimes I'll even combine these methods together that we have to put, right? So that's x minus 2 outside of x plus 3. Right, so PSF is a way that we remember how to factorize those trinomials, right? What actually is a trinomial there? 3, okay, tricycle, right? So that's when we have 3 terms. And as an example, something like this maybe. No, just one. And so just as a reminder, PSF is, okay, I've got 3 terms here, that's a trinomial. And to use PSF, we generally say, I'm looking for what multiplies to this number here, -2, what sums to that middle, the coefficient of that middle term, which is in this case 1. And I want my factors. I want 2 numbers that do that. So 2 numbers that multiply -2 and add to 1. What would that be? -2, 1. So do those, they do multiply -2, do they add to 1? Right, okay, so again, just being careful with all these. It can be confusing to have them all together. We do want to make sure they meet both conditions. So they 2, -1. They both multiply to give me -2, and adding them together, they do give me +1, right? And going back to what Christian said, right? We're looking at introducing brackets. So even though there's nothing in common here, as long as I can introduce brackets and I don't change the expression, then I can actually factorize it. Or if you want to think about it, have 2 things that multiply that give me that expression, right? So in this case, here are my 2 brackets. These are the 2 things that are multiplying together. What would these be? Well, these are my factors here. So it'd be y plus 2 and y minus 1, making sure that we've got those signs there. Okay. And we could expand that out and we get the same thing. All right, last but not least, got this guy. What do we call these kind of trinomials? Because there are 3 terms, but they're a special kind. Yeah, okay. So what does that mean? Non-monic is when we have the coefficient of that x squared term not being 1. So you can see it's a 5 there, right? And we can still use the PSF method, but it is going to change how we do it slightly. Instead of considering just the product as that last term there, we now need to think about, okay, what's the product of the coefficient of this one and that last term, right? So they need to multiply to give me 5 times 6, which is just 30. Still summing to -13 though. So I want 2 numbers that multiply to 5 times 6, or 30, and -13. Yeah, was it? -10, -3? Yep, cool. Because 2 negatives multiply, give me a positive, adding them together, I get -13, right? And whichever process you think in terms of determining those factors, I usually start from like 1 and then go up from there and see if any of those meet that condition. Also being aware that we've got negatives, so we've got to consider that. From there, then we're going to do something slightly different. We can't jump straight to the brackets just yet. We usually break this up into those factors first, which is what we were talking about before. So 5x squared, and my factors are -10x minus 3x plus 6. And then tell me, Angus, what kind of factorization would I want to do here again? Simple one. So what, something in common between all of them? Grouping in pairs, right? Because there's 4 terms. Okay. So you can see there's almost a problem within a problem. This is our original problem here. But in order to get to our answer, and our final answer, I want 2 brackets at the end of the day. But in order to get there, I have to do some other process first. Okay. I have to use the grouping in pairs. So I say, what's in common between the first 2 and then the last 2 there? So in these first 2, 5x outside of x minus 10. Minus, right, okay. So sometimes with the negatives and positives, it can be a bit funny. To make it easier for yourself, yeah, right, thanks. Good spot. To make it easier for yourself, you really want inside the brackets x minus 2, right? So in order to get that, we're going to have to think, okay, I want that coefficient of x, I want to get rid of it. That's why I'll take out the negative 3 as well, and that would leave you with x minus 2. And then you've got your usual way, okay, that's just these guys in common now, which is our simple method. And so that's x minus 2 outside of 5x minus 3. Now in your answers, they actually generally write it with the coefficient that's not 1 in the front. But because we know with multiplication, the order doesn't actually matter, right? But generally in your answers, you'll see this written like that. Cool. It doesn't matter. No. But just for your reference in your answers when you're checking them and stuff like that, it is the same. Okay? Cool. So that's a bit of a whirlwind through factorizing. I'll put the homework up tonight, and don't fret, it's not due by next lesson. But have a crack at it. The more you do now, the less you have to do later. Okay?